The objective in 1.1b is to understand what a postulate is and to use it to solve problems. So a postulate is a statement that is accepted true without proof. It's also known as an axiom. So axiom is just another word for it. You will see either postulate or axiom. Postulate is just like a fact. Some mathematician a long time ago proved it to be true, so we know it true. Okay? It's true. We don't need to prove it. What they say in the postulate is true. Yep. The 2-point postulate. Through any 2 points, there exists exactly one line. So we have a point here and a point here, and we can only have one line that goes through both of these points. We can't have a line that goes like this. That's not a line. That's a rainbow. Remember, lines have to be perfectly straight. So if we have a point here and a point here, there can only be one line connecting these 2 points. So that was a 2-point postulate. Now we go to the 3-point postulate. Through any 3 non-collinear points, there is exactly one plane containing them. So here we have 3 points, and we can only have one plane that contains those 3 points. If you had a plane like this, that contains 2 points, but not all 3. So that wouldn't work. So only one plane. If we have 3 non-collinear points, only one plane can contain those. Flat plane or plane line postulate. If 2 planes lie on a plane, then the line containing those points also lies in the plane. So as we see here, there's a plane, we have 2 points, and a line that connects them. If these 2 points are in the plane, then the line must be in the plane. You could say, what if the line goes on forever? Then wouldn't it not be in the plane anymore? It's not in that purple box. But the plane continues on forever too. So this would be, like, this is part of the plane. The plane is this sheet of paper, but it goes sideways forever, forward forever. It's just a flat box with no thickness that goes on in all directions forever. So if I had a line on 2 points on here, a line containing those, then they're in the plane. Okay? Intersections. Intersect means to cut, means to meet or cut through. Intersection of 2 figures is the set of points that are in both figures. Dashed lines in a diagram indicate the parts that are hidden. We went over that already. So here we have 2 planes intersecting, which are the purple one and the orange one, and 2 lines that are intersecting, which is line AC, this one, and line BD. Line intersection postulate. If 2 lines intersect, they intersect in exactly 1 point. So if I had a pencil, can I borrow this? And another pencil, and they intersect, they are going to intersect in exactly 1 point. If this continues on forever in this direction, and in this direction, and in this direction, now in that one, they'll never touch again, right? Because this one's going that way, this one's going that way, like they're never going to touch. 2 lines intersect in exactly 1 point. Plane intersection postulate. If 2 planes intersect, they intersect in exactly 1 line. Okay? If you have the front wall, this wall right here, this is the brown plane, and the floor is the purple one. They intersect in exactly 1 line, which is this intersection, the molding right here. They intersect in exactly one line. So in this picture, these two planes intersect in exactly one line right here. They will never intersect in another place besides that one line. Okay, now we have review questions. Plane M and plane N intersect in a line segment. True or false? This would be false. They're two planes. They intersect in a line, not a line segment, right? Because the planes continue on forever in this direction, this direction. So this one's going this way. It's not just the box that's shown in the picture. They continue. So it's not going to end at this segment, CE. It's going to continue. So these two planes, plane M and plane N, intersect in a line. Because a segment is just part of a line, but a segment has two endpoints. Lines have no endpoints. Two intersecting lines meet in exactly 1 point. True. Right? For which one? Point A, C, and D are coplanar. True. So let's look at A, C, and D. They all lie on the red plane, which is plane N. So this is true. An infinite number of lines can be formed between points C and D. False. If we have 2 points, only one line can go through those 2 points. So there's the only line that can go through C and D is this point here, which you can barely see anymore, but that's line T. So line T is the only one that's going to be able to go through C and D. 5. Points F, D, and B are collinear. So let's look at F, D, and B. It kind of goes like this, right? That's not a straight line. So they would be non-collinear. So this is false. Because in order to be collinear, you need to be on the same line, which means it has to be exactly straight.